Suppose the relation R containing the ordered pairs 1, 2, 1, 1, and 2, 3 is defined on the set A, having the elements 1, 2, and 3. What minimum number of ordered pairs which when added to the relation R makes it a transitive relation on the set A? Let's try to understand the problem here. So here we have a set A containing the elements 1, 2, and 3. And this is given to us, this is provided to us, and we have a relation R which is this set of ordered pairs 1, 2, 1, 1, and 2, 3. Fine. Our goal is to find out the minimum number of ordered pairs which when added to the relation R, then R becomes a transitive relation. For this, let's quickly go through the definition of a transitive relation. The relation R on the set A is such that R is going to be transitive if the ordered pairs A, B and the ordered pair B, C, if both belong to the relation R, then it should imply that A, C must also belong to the same relation R for all values of A, B and C picked up from the set A. Now, it's very important how we choose the two ordered pairs. The second element of the first ordered pair, which is B, must match with the first element of the second ordered pair. That's also B. Only then we can say that A, C, this new ordered pair becomes an element of the relation R. So for our case, so here in our case we see that 1, 2, these elements belong to the relation R, and then we have the ordered pair 2, 3 belonging to the relation R as well. And this must imply, if R is to be transitive, then it must imply that 1, 3 must also belong to the relation R. Now since R does not have that element, so that means the minimum number of ordered pair that must be added to the relation R should be 1. So that means the R must contain the ordered pair 1, 2, 1, 1, then 2, 3 as well as 1, 3 to make it transitive. So to be a transitive relation, it's going to then be a transitive relation on the set